I opened the IFM up and installed, it's actually a multi-system card, but it has a Wi-Fi direct web server card built into it too. So, hey, look at that. We're in it. We're already in, and we can see our box temp. That's really cool.
This video is brought to you by Heatcraft Refrigeration Products.
All right, we've got a very old evaporator coil that has multiple refrigerant leaks in it. It's older equipment. The customer has opted to replace it. What we're gonna do is we're gonna go through the process of sizing the equipment, making sure that the correct delivered capacity is installed for the new equipment. Oftentimes, I suspect that this equipment is oversized. It's very common to see oversized equipment in the past. In the late 80s, early 90s, even into the early 2000s, a lot of the equipment was massively oversized, and that is creating issues with newer refrigerants and things like that, because it's just basically creating issues. I shouldn't even say newer refrigerants, newer style of efficiencies, scroll compressors, things like that. We're having issues with oversized equipment. It's causing higher TDs, shorter run times, just all kinds of issues with that. But regardless, it is time to replace this. So what we were going to be doing is we're going to be taking dimensions off the inside of the box, the height, the width, and the depth. And we're going to be sitting down at a computer and doing a load calculation to go through this process to figure out what size the equipment needs to be to properly cool this space. Now, a lot goes into play. One of the biggest issues is, what kind of product are we storing in here? We are storing kegs of beer, okay? We do have some bottles, and that does come into play because you don't want too much humidity in the box if you have cardboard boxes like they do, because then when someone goes to pick up the cardboard box, the bottom will fall out. So we gotta be concerned about that stuff. We're gonna take that all into play when we go into our load calculation software. So I'm gonna take some measurements, and then we'll sit down in the office and come up with the size of equipment that we need to properly cool this space and have it continue to run for years to come.
At this point, we have already collected all the data that we needed from the customer. The box dimensions, the box location, the voltages of the evaporator downstairs, the condenser upstairs, the approximate length of the line set as it exists, and now we need to go ahead and select our equipment. So I'm at Heatcraft's website, heatcraftrpd.com, and we are going to go ahead and go to the box load calculator right here. We're going to hit detailed box load. And from this point, we're going to select everything. It's pretty cookie cutter when it comes to this, but we have a rectangular box. We're sizing a general walk-in cooler. Our box location is indoors. I'm going to go ahead and change the box location's temperature, the ambient temperature around the box, to approximately 85 degrees because this customer does not have a very good air conditioning system in their kitchen. We're going to go ahead and set the wall height at 9 feet. One wall length is at 7 feet. The other wall length is at 8 feet. And we're going to go ahead and go on down the line. Now, if you look right here, we have a safety factor that's already built in, and that safety factor basically considers a few different things. It's kind of like fudge factor, okay? When you click the little thing right there, it tells you what it does. Well, there's already a 10% safety factor built into this load calculation. So don't add anything else because there's plenty built into it, okay? As we're going to go down the line, we're going to adjust some things in the wall load, okay? Ambient temperature around the ceiling, we're going to go ahead and leave that at 105 degrees because this is in a very, very hot location. The flooring temperature, I'm going to go ahead and bump that up to 75 degrees. It is concrete, but it gets extremely hot in the summertime here. So we want to make sure we have plenty built into that for the actual concrete temperature. The materials, everywhere else, the ambient temperature, that's all fine. And then we're going to go ahead. You can do edits on the walls if you want to. In our case, we don't really need to add an edit to the wall because there's plenty built into that, okay? Let me just review this information right here. Flooring temperature, that's fine. Everything's good there. I'm pretty comfortable with that number right there. Next thing you do, we're going to go down to our air load. Let's look and make sure everything's where we want it. Again, this can be a little misleading because it says ambient and outside. That's outside the box, but the box is located inside the building, so keep that in mind. We have a standard door, nothing funky about the door, so we're good on that. Let's go ahead and go down on it here to product load, okay? So what we're going to do is we're going to select beverages. Entering temperature of the beverages, about 40 degrees. That's pretty accurate. The other thing that they have a large quantity of is kegs inside there. I'm going to go ahead and take just the generic 1,000 pounds that it gives you automatically. I'm pretty comfortable with that number right there. All right, so we're good to go as far as the load calculation for the actual kegs and the box. I'm comfortable with that. And then right down here at the last one, miscellaneous mode or loads, if you want to add anything, if you got any special lighting or anything like that. Okay, so at that point, we have a required capacity of 5,469 BTUs, okay? At this point, what we're going to do is go down here to select equipment. We have, yes, I want to leave this, and we have decided that it's time to go through and select the equipment. So we have a system, a split system. It's air-cooled, that's correct. We're going to go ahead and hit select, and we're going to move on to the next step. Okay, once that loads, the box temperature where the condensing unit is 105 degrees. All right, we've got the box temperature set at 105 degrees. We want one system, 2008 3-phase on the roof. Downstairs, this is all your information right here, but we need to change the evaporator voltage to 115 volts. Go ahead and select that. All right, now that we've done that, refrigerant 448A, the altitude is approximately 200 feet above sea level. They are very, very low as far as elevation goes. All right, at this point, it's telling us there's only one condensing unit that meets our criteria, and that is a 1/2 horsepower scroll condensing unit, okay? So we've selected that one already by default, and that's fine. Next thing is we need to select our evaporator. So we have a few choices to make, and what we are gonna look at right now is basically what's the best bet as far as the evaporators go, and I selected this evaporator right here, okay? And so you're gonna see that the balanced system capacity is approximately 6,200 BTUs at a 10-degree evaporator TD, a 22-degree suction saturation temperature with approximately 14 hours of runtime. Now you can go around and play with the different pieces of equipment, selecting different evaporators and see the different results, okay? That's very important to understand that. So with that being said, we know what we need. We have our evaporator selection, the model numbers right there. We can go ahead and view a summary, and the summary is going to give us all the information. Now, this is for pre-configured equipment, so my exact model numbers are not going to be identical, but this is going to get us in the ballpark, and now I can go ahead and purchase my equipment and do the installation. Working in my messy shop today, we're prepping this evaporator coil and this condensing unit for a new installation. So on this one, we're going to be using the IFM field mount controller. When you are using the new IFM, you got to make sure that you order the correct expansion valve, the correct transformer, and the correct power harness. So I happen to have all my stuff. We're going to get it installed and then get it all prepped for the job. Open up the kit. They got plenty of instructions. They've got new wiring board, all the cables for a standard installation, which we have longer ones. So we're going to go through the instructions and get everything mounted up. The controller itself is mounted down here, right there. So that we're not going to be getting into today because that's going to be installed on the job site. Today we're going to be mounting the terminal board and all the other components. It's coming time to put the nozzle. If you look at the side panel of the unit, it tells you, depending on the nomenclature, the model number, mine's a 55 and we're using 448A. So it looks like for 404 we would use a 1/3, but for 448A, 449 we're using a 1/2. So a 1/2 is what we're going to use for the nozzle. So it comes with two of them. It comes with a 1/3, and then it comes with a 1/2 right here. So I'm going to get that nozzle put in there. That has to be in there no matter what expansion valve you have on there. That is a very important part of the install. All right, we are all put together. Solenoid magnet, EEV's open. We're purging nitrogen through the system. We're going to get this all set up, brazed in real quick.
It's always good to make sure that the nitro is flowing through. This EEV comes already open. I put a magnet on it just to make sure. We're good to go. We're gonna go ahead and assemble this guy. I put an extra port right here just for troubleshooting reasons. So we'll put a Schrader in there, call it a day, put our pressure transducer right here. Put a little nylog right here to lubricate where the flare nut, and I personally prefer to put a little bit of nylog on the threads too. Just use the blue. We'll go ahead and tighten this down, and then what this is gonna do is this is gonna point out if we need to access the system pressures, and the pressure transducer will end up going on this one. Just want to make sure, personal experience, that the pressure transducer isn't facing down, because sometimes what I've noticed is you can have like oil issues where if you have a thing right here, sometimes there'll be oil trapped in there and it can mess with pressure transducer pressures and stuff. So make sure it's going off to the side. That's my personal opinion on it. I've never read anything that says otherwise. It's just common sense to me. All right, this guy's ready. Got the coil put on it. Everything's good. Got a solenoid valve installed. Yeah. Only thing I would change is prefer to use a Sporlan EEV. But the Corrals work when they're installed properly. Make sure you braze with nitrogen. All good with that. So we're good here. We do have a Schrader just like from the factory underneath the pressure transducer, so someone can change it. This port right here is just for diagnostic purposes. If we ever have an EEV not opening or a solenoid not opening, we can then theoretically get onto the roof, check liquid line pressure, get in between the EEV and the solenoid valve, check pressure, and then you can always check pressure coming out of the EEV right here. So evaporator's ready. Got to still hook up like the comm lines and sensors and everything, but that's not a big deal. Now I'm working on the condensing unit. Got a safety switch, 3-phase safety switch mounted right here. This is 3-phase. Got some wiring right here so that way we can hook it up to the line voltage coming in from the breaker. We'll make some sort of a splice in here, and I'm just kind of cleaning up some stuff in here. We're gonna verify the pressure control settings and just try to get everything ready for the job. Today I'm gonna get started on replacing this equipment, but it's going to take some prep work, so I'm not doing the changeover today because we're going to be going to a new evaporator fan or a new evaporator, and I got to do some electrical work for it, get the controller mounted. So we're not disconnecting anything, just kind of prepping, getting some conduit ran, so that way it makes the job go smoother when we come later this week. We're also going to be lifting the equipment, the condensing unit, onto the roof today. Up on top of the box is kind of a mess. This is a problem for another day, but all the insulation is falling off of the return for the AC. So that's a problem. That's how you find this stuff. But I will say, a couple years back, I posted that they had a bunch of stuff stored on top of the ceiling grid. They got it all removed. I just moved it over here. But in the past, all this crap was just stacked on top of the ceiling tiles. And then like, look at this. This right here, this whole grid is broken. The pieces are missing from it. Like I just told them right now, you guys are gonna have to solve that problem, because I don't want people blaming me for crap falling on people. But what I'm doing right now is we are going to have to run electrical and stuff. We're going to have to find the electrical for the coil, which I believe is that conduit right there going over and down. Someone left an old glycol unit up here, which is annoying. I think that's a pretty good spot. Gives me room to come in, conduit, and then 3 conduit knockouts at the top. Should be able to come up through that section right there, up on top of the box. So we're gonna have to have one for just sensor wires, one for low voltage, and then one that is routing high voltage to the solenoid valve. Yeah, that should be good. Oh, and then the fans. We're gonna have to have the fans coming in here too. So the high voltage for the solenoid can have the evaporator fan motor high voltage in it too. This is my junction box for the power going to the existing walk-in cooler coil. I was a little worried because there's a receptacle and they plugged their glycol unit into it. Also, the glycol unit was smashing my suction line. Silly, someone moved it or something. We'll have to figure that out. But I was looking in here and I was worried, but no, they're just using the same junction box. This is my power for my walk-in evaporator right here, and the only thing they're doing is sharing a neutral because it's all going back to the same panel. Which should be fine. Everything else is on its own power source. which should be good. I'm looking to make sure. Yeah. So the black wire is my 115 volts for my evaporator coil, ground, neutral, and then the red wire is power for this light that's up here. So that's good. Okay, not too worried about that. I've got a 3/4 conduit coming into here. That's what I got to do, run the conduit right now, get the wires ran. I'm not going to hook up power to the controller right now, but we're just getting it all wired and ran. Another thing to note too is when you're working with Intelligent, you want independent power sources. You don't want to be, you know, running lights and different things off the same power source, because they don't want any voltage drops causing their controller to lose voltage or anything. So that's really important to understand that. New condensing unit right here, and then we're just using the lift to get it up. Keep going, a little bit more. Push it in. A little bit more. Maxed out. All right, that's good. Come on up. All right, cool. So we're gonna get this moved over to where it needs to go, and then we'll be done for today and be coming back another day to do the actual startup and install. All right, this is the unit it's replacing right here. Shouldn't be a big deal. We're gonna reuse a lot of the piping. We'll just get new insulation on it, because it's all good, right size and everything. Everything should be good. So we're gonna disconnect this when we come back. Piping's all right there. We'll slide new insulation on it. We are back. It's early in the morning. We're going to start by pumping down the condenser. So we're going to front seat the king valve on the receiver, and pump all the refrigerant into the receiver. We'll disconnect it right here, and then we will recover the gas down on the ground. So I'm just going to get this going real quick. I shut off the disconnect switch. So all that I need to do is open up low side. Looks like we got some sort of a right there. Okay, little fudged up, but again, we're changing it all, so it doesn't matter. And then what we're gonna do is front seat this king valve right here, so that stops the flow coming out of the receiver. Then I'll go turn the breaker back on, and when I turn the breaker on, the compressor is going to continue to pump, and it's going to try to cool the box, but the refrigerant won't be able to leave the receiver. So we've got pressure on both sides, and we'll just go flip the breaker on. There we go. We should be back on and running, and we're just going to watch it pump down basically. So the refrigerant is no longer allowed to leave this pipe right here. So we'll see the sight glass start to drain. See, the liquid is stopping, and then what's happening is the low side is going to start dropping slower, slowly dropping until the low pressure control right on here, this port right here, senses that it's low enough, and it's trying to protect the compressor. But in our situation, we're using it to shut the system off. But that's the whole point of the low pressure control and the high pressure control, is to protect the compressor from a situation where it'll either overpressurize or underpressurize. So once we get it completely pumped down, then we'll be safe to cut it here and cut it down at the evaporator. And then, like I said, we'll recover down on the ground. Now, the condensing unit's still in pretty good shape, but we're not going to reuse it for anything. We'll just go ahead and get it off the roof. We'll probably have to take it apart in pieces because this guy is heavy. It's a heavy, heavy condenser. So we'll have to deal with that in a little bit. All right, we're making progress. We got the coil out. I got Will up on the roof doing the condensing unit. Robert and I are down here. So yesterday I marked the center point right here. This is the edge of my coil right here and right there. So we'll go ahead and get the new coil mounted, and then we'll figure out where all the holes and everything need to be. Tiny coil, huh? Itty bitty little thing. So we are running to the hardware store, getting, we need to go get a P-trap and then get the bolts. We put some tech screws in temporarily, and then the line set will drop down. We're gonna put the line set in the same hole, drop it down, do a P-trap over, and then back in. And then, yeah, should be good. So, and then we'll redo the drain once we get it all put up there. It's turning out pretty good. We got it all bolted up. We put the long ends up top. Solenoid magnet on there. We got some nitrogen flowing through. We're gonna prep this, fit it all up with pipe, and then we'll do all the brazing once everything's connected. But I'll put a P-trap right here, right into the coil. Fitting this up right now, and sometimes it can be tricky. So I've got this 3/8 piece right here that's gonna bend from here to here. And when I'm cutting this line right here, it can get kind of tricky, because if you cut it too far, then you got a burr in there, right? And then you got to deburr it using the deburring tool. But it's best to deburr when you're facing down. Like this was really easy to deburr because the odds of something going in vertically, like going up, is not going to happen, right? So what I do right here is actually just score the pipe. Score it and then break it off. So one more slight cut, and that should be enough to where it's not completely cutting all the way through. Let's see if I'm right. Maybe it's not enough yet. Let's try. There we go. So it broke it off, and there's less of a burr. There's actually, like, the burr is non-existent whatsoever. So if you can ever score the pipe like that, that's your best bet if you're not able to deburr it. So now we're installed. I've got nitrogen flowing through the liquid line from up top, got the solenoid magnet right here. The EXV is open, so it's flowing all the way through, flowing back out, going back up top, so that we were brazing without all the carbon buildup. It's super important when you have EEVs. I mean, it's important all the time, but EEVs are very critical. Yeah, so we're basically ready to braze this guy up. Okay, we got it all brazed in except for this last one, because I have to slide insulation on. Up into the thing, hold it back, braze this, and then we'll be done. Currently doing a pressure test. Got it on the tightness test setting right now, so we're gonna let it run for a little bit. Will did a nice job with the piping. Now, I'm not a huge fan of the Hydrosorb clamps. I like the Cusha-Therm clamps better, but that wasn't part of my quote, so we put back what they already had here. But yeah, the piping looks good. You did a nice kick up on the liquid line. I like that. Right into the thing. And he's just working on electrical now. 3-phase. So we had a conduit right here that wasn't long enough, so we had to pull new wire back through into the panel. And we're just gonna run it over here. All right, we are doing good. Will's just about done with the electrical. Got the vacuum pump running. And I got to go down and finish all the control wiring and everything. All right, we are to the point where we're ready to pull all of our electrical and sensors in, and they're all ran into conduits in here. So we just need to pull that through. The vacuum's still running, and then once we get that through, we can start it up. Oh, we still got to do the drain too, but that'll be so quick. I got to do a little bit better of a job zip tying, but we have excess sensor wires, and I'm just zip tying them in this box. We pulled what we needed down, and we're going to do the same for the EXV cable too. That is just going to be for the sensors, the EXV cable, and the, I'm trying to think, oh, the EXV cable, and I think the pressure transducer is going to go through the same conduit is what we're going to do here. So we got our extra cables in there for the EXV and the pressure transducer, and then we're currently working on pulling power right now. Let's hope that nothing blows up. We're going to hit start right now. I think I did it right. Well, looks like it might be right. Interesting. Okay, let's go through 9, 9, 9, 9, 9, 9, Configure from EV, yep. It's discovering the evaporator. One EV found. We're gonna call it cooler. It's fine. Cooler. Condensing unit wired, no. United States. Let's go the other way. We're gonna do our time zone. Pacific. Daylight savings. I'll make everybody happy and say yes this time. And then I just need to set the date. What is today's date? 23. Oops. Dang it. What do I get back? Maybe. There you go. There you go. 23. December 19th. What time is it?
2:37.
2:37 p.m. Refrigerant 448A, EXV Corel. You can use other types. Defrost air, defrost timed, box temp. We're gonna go with 36. Unit configured. We're not gonna start it yet because I need to go make sure my tech on the roof is ready for it. All right. Should be on monitor. And our fan should be going to low speed. Pretty sure that's low speed.
Yeah.
And then when it kicks in, listen for the solenoid valve. You'll also hear the EXV go da 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 da. Actually open this up just so you can see it. So it should be coming on here in a minute. We're just waiting for it to come on. Well, the fans didn't blow up, so that's a plus. Solenoid just turned on. EXV's moving. Yeah, so we are on and running. It is cooling now. Awesome. All right, it is all cooling. Everything seems to be working, so we're charging it right now. I'm closing up the panels, and I got to work on the drain and get that done before it starts dripping on me. All right, we are doing good. We're currently adding the flooded charge right now. Heatcraft says that the total charge on this system is 9 pounds. The sight glass cleared, what would you say, around 7 pounds?
Yeah.
Probably around 7, 6-ish pounds, somewhere in there. So we're gonna go ahead and put in the max charge, which is 9 pounds. That's the maximum amount of refrigerant the system can hold. That should be plenty for the flooded charge. I am gonna come back and follow up too, but we are running. Everything is good. It's coming down to temp in the box. We're just kind of in cleanup mode. And like I said, I gotta go do that drain now. I gotta say, I'm really starting to like the press stuff. When it comes to like drain lines especially, it makes it so nice just to be able to go boom. So I'm just gonna press these other ones. I did have to solder the union because they didn't have a press union at Home Depot. But I just need to do these other fittings real quick. Condensing unit turned out nice. Looks good. I like it. Nice and pretty. It's got a tube and fin condenser. I was surprised by that. All right, got insulation all the way back. Box is just about down to temp, if not already. 36 degrees. Actually, that's the set point. So I think it's off. Let's see. Oh, 39. Oh, okay. Never mind. Yeah, it's at 39, so it's almost down to temp. I'm currently over here cutting ceiling tiles because there's some messed up ones, so we're helping them out there. Well, it is the next morning. I'm back out here. Let's open this guy up. December 20th. Let's see. Operating mode, it's satisfied at the moment. Box temp is 36.2 degrees. All clear. Everything's good. Have a look in here. Nice and cold. It's not iced up. I think we're good. A little dirty. Still some leftover debris from yesterday, but I gotta finish up some things. I'm gonna install the web server card on the controller, seal up some holes. There's a hole right there. And I just wanted to generally follow up on the equipment. I opened the IFM up and installed, it's actually a multi-system card, but it has a Wi-Fi direct web server card built into it too. So you can use just Wi-Fi, connect to your smartphone, or you can plug in Ethernet
The customer's currently talking to their IT department, seeing what they have to do to bring an Ethernet cable over here. But for now, we're going to try to fire this up and connect to it and see what kind of features we get. All right, now that I've got the multi-system card on, we're going to come over here and we're going to navigate to I think that's the IP address, but we got to connect to the Wi-Fi first. So it's asking for default password, which is in this situation 9s. There, hit join. Let's see if we connect. And then once we connect, we should be able to navigate. Yep, we're connected. Okay, so now just need to go to my web browser and navigate to the IP address. I don't even know where my web browser is. There it is. Alright, close that. And we'll put in the IP address. No, look at all my searches. Alright, 172.168.0.1. Let's try that. Hey, look at that. We're in it. We're already in, and we can see our box temp. That's really cool. That's really cool. You can see our details. That is awesome right now. Wow. Superheat's a little bit low at the exact moment right now. This is really cool. So you can see it's done 2 defrosts. We can force defrost. We can enter service mode. Hey, this is really neat. I like being able to get into this. Super easy too. And I don't know if it's just because I'm accessing it on iOS, but when I tried to use other wireless connections to other manufacturers' controllers, it's been a nightmare. I've had to change like certain settings in my computer and stuff. So it could just be that this is iOS, but this is super easy. So I'm going to navigate through this a little bit more and play around with it. Cool features when I go into system history. You can see all of our temperatures. You can see graphs. You can choose parameters. That's really cool. Yeah, you can do a lot in this. This is really neat. Lots of graphs. EXV information. There's a lot of really cool data here. So something that I knew I needed to do when I came back today was I needed to turn on the 2-speed fan feature because it wasn't doing 2 speeds. So we're going to go in here through the settings and turn it on. I'm currently in service mode. You can adjust superheat, change the fan to a 2-speed. And I successfully put the 2-speed fan on. So it's running on low speed right now, and then when it calls for cooling, it'll go to high speed. So that's cool. That's really neat. That was a little journey through my process of sizing and replacing existing equipment. A retrofit installation is what I call that. So first and foremost, let's talk about the fact that I never assume what was in there was sized correctly, but I always take the existing equipment sizing into consideration, meaning what's existing, okay? So I like to do my own load calculations, measure the inside of the box, go through the rundown, and do some different things. I always look at what the equipment was and then try to figure out the logic and why it was sized the way that it was. A good majority of the time, anything that was installed in the 80s, the 90s, and the early 2000s, even to the mid 2000s, is oversized, okay? Load calculations already have fudge factor built into them. That's something that we need to understand, because even I am guilty of saying, I don't think that's sized right. I'm going to go up to the next size. Okay. In the past, we could get away with oversizing our condensing units, but nowadays we can't, especially with AWEF compliant equipment that floats the head pressure down, meaning that the head pressure control valves, the bypass pressures are a lot lower. When we oversize our equipment, it affects the evaporator TD, okay, and it causes issues. Basically, your equipment already changes based on the conditions outside in the ambient. In the summertime, your condenser typically puts out or can the horsepower or the BTU output, that's the right way to put it. The BTU output of the condenser goes down as the outdoor ambient temperature goes up, but then it dramatically goes up as the outdoor ambient temperature goes down. So in the wintertime, that condenser unit becomes massively oversized, and that can create problems. And I have seen problems when you have improperly sized equipment with new technology, new EEVs, and logic built into the controllers. It can kind of mess with things. So it's so important to make sure that our equipment is sized correctly. Okay, that's very important. That's imperative. Now, again, though, once I do the load calculation, I always look at what was there. Okay, and then I'm like, wait a minute, why is it oversized? And then I investigate that. Okay, it seems like they just oversized it, just like typical 80s equipment, or is there a factor that I'm not considering? Okay, so I don't just ignore what was there, but I always question what was there, if that makes sense. Okay, next thing. My process, first off, these videos are never meant to be like a training aid per se. Okay. These videos are a window into how my brain thinks. Sometimes you can gain knowledge from that. Okay. Take that as you will. Always double check. Don't just assume that something that I say is correct. Always double check, do your research, read the installation information, go through it. Okay. Now, when it comes to the equipment that I used inside of here, you guys saw me run through the load calculation. You saw me kind of factor in, and this is a condensed video. Obviously, I spent a lot more time. You saw me installing the equipment, going out and pre-installing stuff to make the day of the changeover easier. Then it comes to installing the Heatcraft Intelligent IFM. Okay. The Heatcraft Intelligent is an existing controls package that is mounted on factory-built evaporator coils, whether it be low profile, medium profile, warehouse coolers, slimline coolers, all that stuff, right? You can get the Heatcraft Intelligent package. Now, what I used here is the Heatcraft Intelligent package, but it's something new that Heatcraft came out with, and that's the IFM. The IFM is an Intelligent, but it's a field mount controller that you can mount up to 40 feet away from the evaporator coil. I chose to do that because I like the idea of mounting the Intelligent controller outside of the box. It serves a couple purposes. First off, it gets it out of the box, so when you're working on the equipment, you don't have to stand there in front of the evaporator fan motor blowing in your face as you're trying to go through the logic. Now, with the Heatcraft Intelligent, it's already pretty easy to get through, but still, you could also solve that by simply putting the multi-system card on there, because if we had a multi-system card, more than you can connect to it via Bluetooth, and you can step down, you can step outside of the box, depending on the signal strength of the Bluetooth, right? But in this situation, I chose to use the IFM because I can mount the whole control outside of there, and I like it. It's a pretty nice setup there. Went through it. A couple things I do have to cover. Number one, I like redundancy. I like to go a little bit crazy with the Heatcraft Intelligent package, right? Whether it be a standard Intelligent evaporator that's mounted inside the box where all the controls are on it, which work perfectly fine when they're installed and maintained properly, or whether it be the IFM kit like I did where I mounted it on the outside of the box, there is no need for a liquid line solenoid valve. I chose to install one just purely because I like redundancy, okay? Same reason why I installed that pressure port between the solenoid valve and the EXV. I like the ability to be able to troubleshoot later. So Heatcraft has a giant capacitor built into their Intelligent setup that is capable of powering down the evaporator on an emergency power down, basically, okay? So it's able to go ahead and shut the EEV. Other manufacturers don't have that ability. You guys can do the math on which ones those are, okay? But I still like to install the liquid line solenoid valve, even though it's not needed, just out of pure redundancy, just because, okay? I like to go above and beyond and be a little bit crazy with my installs. It's just the way that I am. I'm sure there's some undiagnosed stuff inside my head that makes me do that kind of stuff, but it is what it is, okay? So we went through the process. There really isn't anything difficult about setting up the Intelligent already. It's super easy to go through the setup. The most important thing I can say about doing an Intelligent startup is follow the installation instructions. That's the biggest thing. So many mistakes that I have made literally installing Heatcraft equipment majority of the time is because I didn't read the instructions. I have it on video. There was one time I did a pressure test on a system and I ruined a pressure transducer. On startup, the superheat was extremely low. And then I realized, oh, the pressure transducer was reading like 50 PSI off because I overpressurized it with nitrogen. Right on the pressure transducer was a big fat sticker that says, don't pressurize over 150 PSI. I put it to like 200 PSI, 250 PSI. I ruined the pressure transducer. Had I just simply read the instructions, I wouldn't have run into that, right? Same thing. I've ran into problems with Heatcraft intelligent equipment and previous to that QRC equipment because I didn't read the installation instructions when it talks about the electrical installation. On intelligent, QRC, they want you to have an independent power source for the evaporator. Say, some of you might think that's not a big deal, but when it comes to a walk-in freezer, old school setup, on smaller systems, the condensing unit power controls the evaporator. But on a QRC system, which is the old technology that Heatcraft had, or the intelligent system, which is their new technology, they want an independent power source. So you need to have a 3-phase breaker for the roof. And if it's a 208 single-phase evaporator coil for a walk-in freezer, you need to have a 208 single-phase breaker for the coil itself. They want independent power. The biggest issue with that is they use control voltage, 24 volts to run the coil, and they don't want power drops because that intelligent board is very susceptible to voltage fluctuations when it comes to that low voltage power. And you and I both know if you do air conditioning work in the summertime, especially in Southern California, we have lower than normal voltage. I can see as low as 196 volts on a 208 3-phase system in the summertime. That happens. And when that happens, the 24 volt transformer runs into problems and the low voltage can drop. Okay, so we got to make sure you have those independent power sources and your transformer is tapped correctly. So important. Okay, so just it's as simple as following the installation instructions. Once I put that multi-system wireless card on there, my gosh, that was so easy because you could just pull it up on your tablet and you could change all the parameters inside that thing. I thought that was really cool. Personally, I'm going to try to convince my customers to let me install those multi-system cards on all of my existing intelligent equipment because it's going to make it so much easier to troubleshoot when you go through that. Okay. So let's get back to the install. So when I went through, I try my best. I am not perfect, but I try my best to make sure my equipment is sized right, my evaporator's sized right. It's really important too when it comes to the size of the equipment, run times. Okay. Boxes can be sensitive, and I mentioned it in the video. They can be sensitive, the actual walk-in box, to humidity levels. If you got produce in there, you typically want a higher humidity level so you don't dry out the produce, right? In certain situations. But let's say in this case, we have a bunch of cardboard boxes because they keep cases of beer in there. If you've never seen this happen, I have seen this happen, where a customer walks into a box to pick up and they grab the handle of the 6-pack and they lift it up and the bottles fall right out of the bottom because the humidity inside the box was way too high and it was causing moisture issues with the cardboard. So it's so important that you make sure that you're sizing your equipment right and you maintain the proper levels of humidity, whether or not you want it really dry. Like in our situation, we're running just beer kegs. There's no food, no anything, so we can run it kind of dry inside that box, right? So you want to pay attention to that stuff and just make sure you're not massively oversizing your equipment. That's another thing that can happen is higher humidity levels. And you know what I didn't mention in this video? When I was installing this equipment, the manager mentioned to me, he said, hey, when you install this new equipment, is it going to stop the mold? And I go, well, what do you mean? And he goes, weekly, I come in here and I wipe down all the boxes because they get mold on them. Okay. He goes, I wipe them off and then it just comes back. He goes, I'll take everything out of this walk-in, I scrub it down, and then a couple weeks later, we've got little bits of mold popping up. That's a humidity problem. Okay. That's the equipment sizing coming into play. So that's so important that you communicate with your customers. Make sure you're following the installation instructions. Make sure you go through that stuff, okay? There's really nothing too difficult about these systems. I know a lot of people are afraid. Oh my gosh, you've got controls installed in the evaporator. That's the stupidest thing. That's what people say all the time. I have a ridiculous amount of walk-in freezer and walk-in cooler evaporators that have digital packages on them, whether it be QRC systems, which was the quick response controller that was previous to the Intelligent, or the Intelligent system. I have tons of them. I've installed tons of them. with hardly any problems, okay? As long as you follow the installation instructions and the customers don't open up the box and start playing around inside the coils like one of mine just did and short things out, you're really not going to have any issues, okay? But the cool thing with this IFM kit that I installed is, you know, for the people that are worried about having the controls inside the box, I'm able to remote it up to 40 feet away. Very important though, you need to follow the box and the installation instructions. They give you the parts that you need because they can't send out the parts with every box because there's multiple different lengths of cables and multiple EEVs and different things. It's not just one EEV for 30 different walk-in box sizes, right? So you do have to field select your EEV, right? But with the Intelligent, you have the ability to choose other manufacturers' EEVs. So you can go in there and you can install a Sporlan EEV, you can install Carell EEVs, you can install insert name of whatever brand of EEV you want to use, you can install them with them, okay? But you are going to have to make sure that you get the proper EEV cables for those particular EEVs too, and make sure that they have them in the right lengths that, you know, you're specifying for your box. So there's a lot of factors that go into it. It's really important if you're going to do one of these IFM installs, you need to go ahead and get that manual out and you need to plan ahead, okay? Read the manual 2 weeks before you do the job, okay? Give yourself time to order the necessary parts to make sure that you get them, okay? Just something to think about. I really appreciate you guys making it to the end of the video. Hopefully I answered all your questions. If you guys have any feedback or anything else you want to ask me, feel free to reach out to me at hvacrvideos@gmail.com. Feel free to leave me a comment. Let me know what you think. Give me some feedback down on this YouTube video. Let me know. Tell me. If you think I did everything wrong, then give me some feedback. I'm always willing to learn, okay? I'm not afraid to admit that I did something wrong if someone brings it to my attention, okay? Because I try my best, right? I'm not perfect, and I know that I'll never be perfect, but I just try, okay? If you're interested in supporting this channel, there's a few different methods you can do so. The simplest way is literally just watch these videos from beginning to end. That really is the easiest way. You can also support the channel by going to my website, hvacrvideos.com. You can support the channel by going to truetechtools.com. If you purchase any tools from there, you can use my offer code BIGPICTURE. That's one word. You get an 8% discount on checkout. I get a small commission. Just a great way to help support the channel. There's a few things the discount code doesn't apply to, but majority of the items on their website it does. You can also support the channel via PayPal, Patreon, and YouTube channel memberships. There's links in the show notes of this video. Again, thank you so very much. I really do appreciate you, and we will catch you on the next one.